Hello and welcome to the extra video. This one's gonna be really low effort and filled with errors because I just want to focus on other videos at this point. But I might as well share what I did just in case, like on the 0.1% chance someone is interested. So, snapshot 1, snapshot 2, uh, snapshot 3, and we'll do that as snapshot 4. So that's in case you wanted to read all of this. So I don't know, this doesn't deserve to be called a conjecture because I haven't really thought about it very much. And this is directly inspired from a question I saw on Stack Exchange. So I just sort of kind of took the idea and kind of put it in my own words and my own and everything. So we're going to be talking about W minus the omnity element, but you could talk about topologies on W itself if you wanted to. You can do it however you want. This is math. You can do things in many ways in math. So here's the idea. We have a wheel. We let W prime be the wheel minus omnity. We define restricted versions of the operators. These are just the operators of the wheel, but restricted to the wheel without omnity. And the question is, does there always exist a Hausdorff space, a topology on W prime that makes it a Hausdorff space where the restricted operators are continuous with respect to this topology, and where for any x and y in W prime, if x plus y equals omnity, then for any z in W prime, there exists two functions whose limits go to x and y respectively, and whose sum goes to z in the limit. Now, what am I talking about here? So what I'm saying is, if x plus y is omnity, then I can find f and g, functions f and g, such that f goes to x in the limit, g goes to y in the limit, and f plus g goes to any element that I want it to go to. I can find an f and g to make it happen. So, in other words, when x plus y equals omnity, I can construe a situation with two functions that sort of, goes to x and goes to y, but the sum goes to anything that I want it to go to when x plus y equals omnity. Now, a technical detail here is that we require that the functions be such that the sum of them is always defined. Wait a minute. Now I'm wondering if I even need... Is that redundant? Yeah. That sounds redundant. Well, whatever. It doesn't hurt if it's redundant. I guess it's just ugly. But anyway... And then number 2 is the same exact thing, except for x times y equals omnity. We can always find the f and the g to get any limit we want when we multiply them together, while having, one go to x and one go to y. And number 3, the same thing, except when slash x equals omnity, we can always find a function whose limit goes to x, but where the slash of that function is going to go to anything that we want it to go to. And then there's just a little bit of technical language, right? We're just saying that t star is a limit point of the domain of the functions. That way we can talk about limits. And then I just decided to say Hausdorff space so that these limits should always be unique. And If all of these conditions hold, then we say the topology agrees with the wheel. So essentially what this conjecture is it's saying for any wheel, you can turn it minus omnity into a Hausdorff space such that the restricted operators are continuous, and such that if, say, x plus y is an indeterminate form, or if x plus y equals omnity, then x plus y is an indeterminate form, quote unquote. In the sense of like this topology. Now I put this in quotation marks because this hasn't been technically defined what this means. It's more of just like an intuitive, communication. So I do have an example here. So this is the wheel of reals. I actually went over this in the video. So the real numbers plus infinity and plus omnity, we just define that r plus s and r times star are going to take on the same values as they do in the field of reals. And then slash r is just going to be the multiplicative inverse of r as in relative to the field of reals. And infinity is defined as whatever slash sends 0 to. Omnity is defined as whatever 0 times infinity is. Omnity is defined as 0 times infinity. 0 times infinity gets mapped to omnity, right? And then we have infinity plus real number is infinity. Infinity times the real number is infinity, as long as r is not equal to 0. And I believe this should say everything about how arithmetic works in the wheel. Anything else you want to think about, like, I don't know, what's infinity divided by 0? Well, that's going to follow from these things. You just have to, use the axioms and everything, and it'll follow. Which, by the way, infinity divided by 0 is infinity, if you're curious. That's just, not too hard of a one. So we define a topology on R in the standard way. So the idea is if a subset of the reals is such that any point of it has an open ball around that point that is contained in that set, then that set will be in the topology. It will be an open set. So essentially every set, any set all of whose points are interior points with respect to the standard metric, those are going to be the open sets. You could also think about it in terms of open rays and all of that, like an order topology, and I think that'll be the same thing. I'm kind of going quick here, so hopefully I'm not saying something wrong. And then we want to define a topology on R star equals R union infinity, where it's going to take in all the open sets of the topology on R that I just described, plus for any compact set relative to that topology on R, the complement of that compact set relative to that topology on R, plus the infinity element, will be an open set in our new topology on R union infinity. And I just put the closed compact set just because in the general case you would want to also say closed, but technically in this case it's redundant because compact sets of R are automatically closed. So this topology that I just described, I believe, agrees with the wheel of real numbers. And I give a little example. So infinity plus infinity is omnity. So this infinity plus infinity is an indeterminate form. And if f is t and g is t, then as t goes to infinity, f goes to infinity, g goes to infinity. And what am I? Yeah. And f plus g goes to infinity. Yeah. So in that case, infinity plus infinity equals infinity, so to speak. But if I let f equal t plus z and g equal negative t for a z and r, then again f goes to infinity, g goes to infinity, but now f plus g goes to z in the limit. So what I've shown here is that for infinity plus infinity, which equals omnity, I can get the limit of f plus g to go to anything that I want it to go to while keeping that f goes to infinity and g goes to infinity. So if you go back up to the conjecture, that's sort of like the condition described here. I'm showing that it is satisfied in this particular case where x equals infinity, where y equals infinity, and where the wheel that we're talking about is the wheel of real numbers, and where w prime is r star, so the reals plus infinity, but you see, you know, and where the Hausdorff space in this case is the topology that I described on r star. Does that all make sense? And then, of course, infinity is a limit point. So the domain of f and g is all of r star, and indeed, infinity is a limit point of that domain. So, what I've shown here is that for this wheel, and for this particular example, the conjecture is satisfied, assuming I haven't made mistakes. By the way, this conjecture might be incoherent. That's a very real possibility, but hopefully it's not so incoherent that someone can't see what the coherent version of the incoherent thing I'm saying is supposed to be. And it probably has some technical mistakes. It might not be posed quite the right way, but hopefully if it's posed the wrong way, then it's clear what the right way that I was intending was supposed to be. So yeah, that's the idea, is like, I don't know, I was kind of curious about that, because I feel like if this conjecture is true, this is just my limited, you know, sliver of intuition, because I am not up to the task, okay? I don't even know if I'm up to the task of asking the question, much less, you know, thinking about it. But the way I thought about it is, if the conjecture is true, then it says something about omnity. It says that omnity is always going to show up when there is a topological way of thinking about the wheel such that omnity shows up when you have an indeterminate form in some, you know, nicely compatible topology. You get what I'm saying? I feel like it says something about omnity, like it connects omnity to indeterminate form, because when I was looking at the wheel of real numbers, you know, after I kind of went through the technical math, I still didn't get it. And the whole indeterminate form thing is what I felt like made me get it. But the problem with that is I didn't know if the indeterminate form thing was just like a coincidence or something. You know, can you do that with just like any wheel? Because I have a hard time picturing arbitrary wheels. I really don't know what like arbitrary wheels are like exactly. Now the paper I based the video on does actually, you know, go into the technical details of that. I didn't pay attention to the technical details of that. I saw a bunch of abstract algebra and category theory, and I was like, yeah, I'm good, you know. I didn't, you know, I could I have gone through it if I wanted to? Maybe somewhat, but it would have been an enormous amount of work, and, you know, it's not, that's not my goal. My goal is to try to make a video, not to study dividing by zero for, you know, weeks or stuff. Plus, I get headaches and stuff, so studying math is not the easiest for me these days. You know, it varies from being very difficult to being just sort of kind of difficult. But anyway, enough of that. Yeah, so the last thing I just want to comment is that the wheel, if you take the real numbers and add an infinity element, you can create a topology that makes it homeomorphic to a circle. So you're basically turning the real numbers into a circle by adding infinity and doing it in the right way. And it's called a 1-point compactification. Hopefully I'm not making errors right now. There's lots of errors in everything I've written here. There's lots of errors in everything I'm saying right now, probably. But you know, that's why this is the little extra video. Anyway, I'm done. I'm sorry. I hope, you know, the 1% chance that 0.01% people found this interesting, you know, in 1% of parallel universes or whatever you want to say, you know, hello. And yeah, if anyone actually has thoughts about this, let me know, because that might be interesting to hear. Maybe someone actually can settle the problem, fix the questioning and settle it. That would be pretty interesting. Yeah, take care.